designer building. So for us, it's just
LEED, with the exception of a couple things, doesn't add cost, but I'll get into that when we get to that section, so.
Okay, so have you started recording?
Yep.
Yep, okay.
All right, so for the administrative spaces, now I went to the architects, the engineers' website,
Mm-hmm.
and they said that they're using the spaces are cooled by chilled
Beams.
cooling.
Mm-hmm.
So how is that more efficient than just using conventional air conditioning?
Well, what it means is that we are able to displace exactly at the room
Okay.
the cold air. We use the air handler, the way the system works is that the air handlers bring the air into the building, and they will do an initial heating or cooling of the outside air, depending on what the temperature condition is, and then distribute the air to the room. And then at the room, the air is run past these chilled beams. And the way the system works is it's a series of of tubes, basically, within that unit, and the air blows past it and is cooled down.
Okay.
So that you don't have the temperature loss or gain in the air as it runs from the air handler, which in the case of the offices is up on the roof, down to, working all the way through the system, down to the main floor, the main area where you're working. So you don't have to take your outside air and cool it as low as you would need to force it to get it to the space. And then when you get to the final space in the cooling side, typically we would have a variable air box that has heating coils in it to warm the outside, warm that super cooled air back up to a temperature that's not going to make the room a refrigerator. So what happens on a traditional air handler, you're going to take the air from outside and drop that air temperature down to as low as, you're going to run it past coils that could be as low as 41 degrees, and then warm it back up a little bit, put it through the building, and then warm it more at the final space. So in the summer, you're cooling the air and then you're heating it back up again.
Oh,
And so what we can do is that we cool the air. We don't have to take the temperature in that air handler as low, and then you do the final tempering in the space that you're in. So you control the amount of cool air that's running through the tubes in the chilled beams in the space, cooling it to the temperature that you want.
So that creates like a more even, so
It's-
you don't get like hot spots, cold spots.
That has more to do with the placement of everything in the room, but what it really does is gives us more control in the room of the amount of energy we're using to heat the air or cool the air.
Okay, because sometimes when I'm in the library, like in the tier sections, it's extremely warm, and then on the floors it's extremely cold, and I always wonder why.
Part of the problem, like with the library, is you're dealing with a building that has 4 additions on it, so it has 4 different mechanical systems. And the tiers is the oldest section, is the second oldest section of the library. And it is self-contained in the way that it's heated and cooled. And the tiers is just a mess because it's basically a giant 8 stories in the tiers, 7 stories in the tiers,
Yeah, 7.
that's all within a metal framework. And so it's all one big open space within all of the metal framework that hold the tiers and hold all the books. So you can't really control the air in that space as well as we do in modern buildings.
Okay, so this is also the same with the heating with the.
Yep, with the
breathing.
heating, because we use hot water in heating season. We have hot water in the beams because they're a dual beam system.
Okay. I did not know that. There was a
Yep,
dual
we
beam.
use hot water and use hot water and chilled water in the beams in this building.
So we were going to do a cost comparison because there was, the College of Agriculture and Life Science used to be located in 3 buildings. Now it has been put into 1 building. So we were trying to do a cost comparison of what the utilities were, for, like, the average. It doesn't have to be like years worth of, like, maybe a couple of
Yeah.
months of what it was to run those 3 buildings as opposed to what it is to run the biorenewables complex. So is there any way we can get data for that?
Yeah, if you go to the facilities website,
Okay.
fpm.iastate.edu, you can pull up the energy consumption for every building on campus. And when you're trying to really compare the costs for the ABE department, you would look at the utility consumption for Sukup Hall and Elings Hall. And that will give you 2 of the 3 buildings that are in the complex. The Biorenewables lab is not really, didn't have any spaces that the units came from. And then you can also pull up in the building list, past historical data for Davidson Hall should still be there, as well as Industrial Ed 2.
Okay. That is really good information
Yep.
because I'm recent, so I actually joined the college. I'm a transfer student. I joined the college when the construction was going on, so I didn't even know that.
Yeah, we maintain through our website utility data on every building on campus. So you can go look at what the utility consumption is. Now, with the 2 new buildings, it may be higher than those 2 combined, but part of that has to do is they were coming from space, some of it that had absolutely no air conditioning. So, you know, you're going from spaces that either had no air conditioning or window air units, some of them had none, to space that is now controlled year-round.
Okay.
But the best way in looking at would be to really kind of pull the average square foot cost of utility data. So from that building page, it'll give you the square footage of the building, the gross square footage. And what you do is take the utility data and divide it by that gross square footage, and it'll give you a dollar value per gross square foot. That's the best way to compare it because the amount of space that they have now in Sukup and Elings is considerably more than they had in the other 2 buildings.
Okay.
So you can't necessarily do a flat, the cost of this building was
Oh, okay.
$500,000 per year, the cost of this building is $600,000. Well, the problem is the square footage is so much larger than what they have now because they actually have labs that are sized appropriately. They have students in spaces that are adequate. Instead of having 12 graduate students crammed in a 10 by 12 room, you've got 12 students in a much larger space.
Okay, now we're gonna move on to the water management. So they use a stormwater reclaim
Yes,
system.
we-
And how much of that affects the amount of water that the building gets from city or fresh water sources?
We anticipate a savings of, this is what we're anticipating when we do all of our calculations. We're anticipating reducing our potable water use by 97.5%.
And is this also taking into consideration that some years you'll have drought and you'll have a reduction?
It doesn't matter for us. What our testing has shown through the BRL building is from the point that building was constructed to the point that we had to take the stormwater system offline to add on the second cistern that helps serve Sukup and Elings, is that in the 2.5 years of operation of that building, and it went online in summer of 2009, I believe, BRL did, we only used 130 gallons of potable water to flush. We had 2 drought summers during that period of time. What happens with these stormwater reuse systems is we are collecting not only roof water, but we're collecting water out of the footing tile that surrounds the basements. And because of the deep basements in all 3 of those buildings, There's a lot of groundwater on that site, so that's what we're pulling. And for us, it's a savings because we still would have had to dewater the buildings and have the footing tile around the building, but instead of dumping it into the storm system, and just, sending it down line, we're able to use it for toilets and urinals.
Okay, that's why the toilets and the urinals have blue water, 'cause
That's because in the state of Iowa, all construction codes are managed by the code official's office, except for plumbing. Plumbing is managed by the Department of Public Health, and it uses a different code. All of our construction we do under the international building codes, except for plumbing, which is under the Uniform Plumbing Code by Public Health. And when public health is dealing with large volumes of water, we were the first cistern system, we were the first stormwater reuse system in the state of Iowa, here at Iowa State, on our buildings. And public health didn't know what to do with it. And so in order to reuse the water, when we're dealing with large volumes, they're used to swimming pools. So we have to have a recirculating pump in the cisterns that runs 24/7. We have to run the water through a biological UV filter to kill any biologicals in it. And then we have to dye the water so that people know that they shouldn't drink the water in the toilets and the urinals.
That's the only point of it?
Yeah,
Okay.
because public health wants us to know, wants anybody who's around this water to understand it is not safe to drink. And one of our arguments is, at a college campus, we really don't have the issue of anybody using the water in the toilets and urinals for anything other than its intended value, and we very, very rarely have dogs in buildings. And the dogs that we do have are service animals who are trained to not drink out of the toilets.
So the blue dye has no purpose in like making bacteria?
Nope, it is a food-safe dye, and that is solely so that people understand that they're not supposed to drink the water in the toilet or touch it.
Okay.
So
And it's something you know from growing up at home, you don't play in the toilet.
All right.
So does, having all this, recirculating the water and running it through a UV filter, does that also increase your cost?
It does add to the cost of the system. However, in the long run, I think that water is going to become a resource that becomes highly regulated. One of the arguments that we've had that has happened around campus is, this is Iowa, we've always had water, it's not a big deal. Water is cheap from the city. But you really need to start looking at some of the drought issues that occur out in California and other places. There's no intelligent reason on why we are using potable water to flush waste. It isn't. When you look at the number of gallons, and I don't remember, I don't think I've got that in here, the amount of water that is being used to flush, and I don't have the gallons in this one of what it's proving, but we save, I think, and I'm doing this off memory, with the water reuse systems that we have on campus, we save, I think, it's 187,000 gallons for Sukup and Elings that's saved annually by using those systems. That's what we calculate that they would be, the annual use to flush toilets and urinals is 187,000 gallons. Right now, water's cheap, but in 10 years, is water going to be that cheap?
Yeah.
So, in the lifetime of the building, it is probably going to more than pay for itself. And we didn't do this on any of our buildings, just to make us feel better about it. It's looking at the lifetime costs of the system. It does pay for itself over the life of the building. The average life cycle cost, when you look at a building and have to calculate it, it's 25 years. For Iowa State, we anticipate our buildings we're going to have for at least 50, if not 100. You will have to replace pieces of the system, and that's part of the life cycle cost, but unlike most developers, we build our buildings are gonna last at least 50 years. So it does give us cost savings in the end. And the stormwater reuse system on the ABE complex is important because that side of campus has a limited stormwater system to be able to, that connects then to the city system and spins it out. The history of that system, it was installed in the early 50s, and at that point in the master plan, there was never any intention of building a building west of Bissell Road. Buyer was never to be, all the way from Buyer up to town, and then everything north of University, which becomes Pamel, so we're Molly Bio and everything up there. All of that was supposed to be either farmland or undeveloped area, recreation fields, athletic fields. So the stormwater system was sized back there that runs down Bissell Road to have that be all grassland. And to replace the storm system is a cost that the university really can't take on right now because it would, tears up Bissell, but there are so many other utilities that are wrapped around it. It's unbelievably expensive to be able to replace that and upsize it. So the caveat when we built on that site where the ABE complex is, was that the site needed to have less runoff after the building was built, after the whole complex, than before the buildings were put there, when it was just an open green field.
Do you have any questions on this?
No, this is great.
Okay, so wastewater management.
Mm-hmm.
So what do you do with the wastewater that comes from the building? Is it just sent directly to the city or?
Yeah, the wastewater, everything on campus that we deal with goes directly into the sanitary lines.
Okay.
When it's coming out of any drains or toilets.
So there's no attempt to try and recycle part of it, or?
No, Iowa code will not allow us to use wastewater. We can use stormwater. And we have to call it rainwater reclaim. But we are not allowed to use we're not allowed to, by state code, to use wastewater and treat it at all.
Okay, so now we're gonna go on to the LEED certification part. So we've seen the energy saving, the water management. So what other initiatives were also used to attain the LEED Gold certification?
We have not achieved the LEED Gold certification yet. We are still finishing up the paperwork associated with the construction. We anticipate being able to file for the construction review by the end of this month. We're waiting on the commissioning report for the mechanical systems. And typically in LEED filing, on the final filing for review, is anywhere from 6 to 12 months after you move into the building. Because we may have occupancy of the building, but we're still not really done with dealing with the construction part of it. There are things that everybody thinks the building's done, but it really isn't. We're tweaking things, we're making sure everything really is working. We're finishing items in parts of the building that don't affect the use of the building at all.
Okay.
But the paperwork side takes a lot of time on the back end. Really, with the ABE complex, there really wasn't anything that we have to do extra to do LEED, and that's our approach when we come to doing LEED certification on campus. Because we have and manage so many square feet of building, we have a set of design standards. And all of our buildings are set to follow these design standards. And it has to do with, the equipment that we use to put the building together, what we anticipate and what we really demand in energy savings in the building. And a lot of these things really just sort of naturally fit within LEED. And we discovered that when we started doing LEED back with Morrill Hall, is that it was just sort of a good fit with good sustainable management of a building. One of the things that LEED has pushed on campus has been our recycling program of things other than white paper. That really came about with LEED, but it's been something that is the right thing to do. And so it's a lot easier for us to do now than it was when we first started. So now we do have programs on campus, and we do, we do white paper, we do newspaper, we do cardboard. With Iowa, it's very easy to do cans and bottles because they're worth money, and in most cases, student groups associated with the building take on the responsibility for recycling cans and bottles because they can get they then get the 5 cents per can and bottle for use for the student orgs, and that's what we've been able to do with, that's really been the only piece that we don't manage through facilities. Because we do cardboard, we do metal, we do paper.
So, as part of the sustainability efforts, were the building materials eco-friendly, and if not, were they locally sourced to reduce your carbon?
I don't have the final numbers yet on everything, but the big intent with everything that we do is that all of the materials we use in the building are low and no VOC content. That was a difficult thing to do when we started, because when we started doing green buildings, a gallon of low no VOC paint you could only get at Sherwin-Williams, and it was $75 a gallon. You can now get low and no VOC paint at Walmart, and it is. LEED has transformed the construction industry so that it's not a special thing to have to do anymore. And for a lot of these, the material manufacturers, it's good business. On the carpeting side, it's very hard to find carpeting, carpet tile, things like we use, that's 100% virgin material. For them, most of the manufacturers now have recycling programs where if you're going to replace your carpet, they take this back to their factory, they shave the backing material off from the loop, they take the nylon, they refurbish the nylon and re-dye it and make new carpet out of it, and do the same thing with the backing. So, furniture fabrics, materials in furniture, it's really hard to find materials that don't have recycled content that are, on some things you have to be very careful with low and no VOCs. There are certain paints that sometimes we have to use. For example, there's a fireproofing paint that you use on steel. There's no way around it because of what that paint does in case of a fire. It just has VOCs, but that's one of the reasons why we flush the buildings out or air sample the buildings before we take occupancy of them.
What does VOC stand for?
VOCs are volatile organic compounds.
Okay.
And they're usually on just about any building material. You can go to a manufacturer's website and get information on the VOCs or the particulates released from them. One of the other things we work with is looking at not using composite wood, plywood that is made with formaldehyde. Most plywood has formaldehyde in the process of making plywood. It's just the way it's made. And so it's gotten very easy for us to put materials in our buildings that are low and no VOC, that have high recycled content. The biggest problem that we have is finding regional materials, and that has everything to do with where we are located. We do a pretty good job with gypsum board, drywall, and that's because US Gypsum has a plant in northern Iowa. They mine gypsum in northern Iowa and make the drywall here. Steel, we can get local for USGBC, and LEED means within a 500-mile radius of your construction site. Steel for us is easy because it comes from a plant in Illinois, and it's 100%, almost 100% recycled material. It's very hard to find steel that's made out of virgin iron. There may be a small piece of it, but it's very rare anymore. It gets added in. Concrete is sourced relatively locally for us. Part of that has to do with the limestone aggregates that we get here in Iowa and other things. We, on most of our projects, are around between 15 and 23% are kind of the ranges I've got right now that I track, that are regional materials. which means it has to be extracted and manufactured. It's not just from around here, it's gotta be, come out of however it's made here, within 500 miles of the site, and the same goes for recycled content. Most of our new buildings, just because of the materials that are available, we sit around 25% recycled content and everything that's in there. You know, anytime you're dealing with anything that has a polyester in it or things like that, it's not gonna be a regional material. I mean, it's made with oil,
Yeah, yeah.
so
There's, like, we
nylons
have
and
some-
polyesters.
We have reasonable expectation, like, we don't expect all the materials 100% to
Yeah,
be.
but we really have found on our projects that we can, LEED has a minimum goal of 10%, 20% gets you another set of credits, and then over another percentage, I think is over 30%, you can get exemplary performance, because it's just hard to find, no matter where you're building, the ability to get everything that goes in your building within, to have, high recycled content and to be within 500 miles of where you're building. But we pretty much expect somewhere, we're gonna at least probably get 15% of everything that goes into our buildings. We're fortunate in that
Okay.
way.
And then, I was gonna ask, like, how much of an effort was made during construction to reduce the carbon footprint of the project? Like, were they using eco-friendly shelters for the construction workers, or Energy Star appliances?
Really, there's probably not a directed attempt to reduce carbon footprint during construction. A lot of times it takes what it takes. Anymore for us, if we've got all of the contractors we work with, like we have job site trailers, they have a collection of those that they move from project to project to project, and you use them until you can't use them anymore, and then you get a new, so it's not like every single project's gonna get a brand new trailer and all these other pieces. We do have to maintain, controlled temperatures. We try to do everything we can to not do a lot of energy consumption during construction projects. We do encourage all of our contractors, we have a limited area that they can park, so we do encourage them strongly to carpool. They, like students, are encouraged to park out at Hilton and either van pool in their staff every day or have them take the bus into campus. Those are the things, but part of that has to do with just the limited area we have on campus. We can't have every contractor that we have park near the construction site, just sort of like every faculty member or staff or student. There's just no way everybody can park next to their building or go from building to building during the day.
So, for the green roof, is it effective year-round, or is it just seasonal during
The green roof does a lot of its stormwater management capabilities just like the ground. If the ground is frozen, the green roof will be frozen. And if we get rain and everything's frozen, then no, it's not gonna filter, just like, it really just functions just like the ground. And so with the green roof, the media that's up there, as long as it's not frozen, and it thaws really sooner than the ground because it's only 2.5 inches thick versus feet of. The growing media up there filters the water and gets a lot of particulates out of it and cleans it before it goes into the stormwater reuse system. And really, the fun thing about the green roof is the plants are up there just to keep the growing media, which is the filter media, from blowing away.
Okay.
The plants do draw some water back out of the green roof and allow it to evaporate, but the growing media of the green roof holds water and will evaporate water out of it just as well. The plants just help hold everything in place. And it looks a lot nicer.
Yeah, I saw we saw the website for the company that actually
Mhm.
did it, and it looked really nice.
Yeah, there are two different roofs on the building. They're on the lower level that you can see from the walkways on the second floor, on the north and south side that are over the entrances. Those are a tray system roof that's done by Rooftop Sedums. They're a firm out of eastern Iowa. The upper roof is a planted roof, which means we put down all the growing media and then set the plants in it to have them grow. The tray system roof comes to us fully grown. And so the two roofs that everybody sees all the time looked mature the minute they went in. The roof that's up on, the high roof will probably take another, it looked okay by the end of last year. It really should be more fully established by the end of this growing season.
Okay, so now we're almost at the end.
Okay.
We're now going to talk about electrical consumption. So, are all the lighting needs in the building Energy Star?
No, Energy Star doesn't rate light fixtures.
Okay.
Energy Star does appliances.
Okay.
And so what we have in the building, we have lights that are tied into motion sensors and into daylighting sensors. So, and part of that, we started doing that because of LEED, but now the building code and the energy code have changed that force owners to do this. So in almost every regularly occupied space, there is it's actually a lack of motion sensor. And that if there is no motion in the space and it is unoccupied, it will shut down after a set period of time. And a lot of those sensors, you look at them, they're kind of rectangular in shape. There's a button on the top and sort of like a clear globe on the bottom. A lot of the bathrooms around campus have them. And they will turn off, they will sense motion when somebody comes in, and if there is absolutely no sense of motion, in most times, at times 20 to 30 minutes, it'll automatically turn the lights off. That's a major energy saver. And in a lot of the spaces, we have limited daylighting controls. And what that does is that, imagine in, this room where you've got a light fixture that has 4 lamps in it. And if there really was a window on the end of the wall, it would sense that there's enough light over there that you only need to turn on 1 or 2 tubes if you need to get up to a working lighting level. Or if it's nighttime and it gets dark, then it'll say, then all 4 lights come on.
I've noticed that when I'm in like Walmart or something, the lights are shutting off and turning
Yeah,
on.
those are sometimes, it depends on what you're looking at. Sometimes they're tied to a lighting monitor and a motion sensor. So if there's adequate lighting and motion, they're not gonna turn on at all. If there's not adequate lighting and there's no motion, they're gonna stay off. If there is not adequate lighting and it senses somebody, it's kinda like the freezer section at Hy-Vee. If you walk down the freezer cases, those are all on motion sensors, so that the lights automatically turn on when it sees somebody in front of the freezer case.
Okay.
And so those are all tools that we use in our buildings really to run the occupancy of the lights. The daylighting sensors are really helpful. And they can be overridden, but most individuals won't. And we try to set the controls in such that the ones at Walmart are really, really fussy at the lighting levels because it's like up, down if the clouds go by. What we try to do when we do them on campus is set the control that, it kind of, if the lighting is changing every 30, if the light level is changing like every 30 seconds, it's not going to turn the lights on, turn the lights off. It's going to sort of sense it, and after a couple minutes, if it's dropped down, then it will turn another light back up or turn it down. But on, a lot of our Iowa days, we get these really big fluffy clouds that will come through, it'll darken it down, and then it lights back up again. We're trying to help modulate that. Early lighting controls were really fussy in turning on, turning off, turning on, turning off, and you just don't you can't do that in a regularly occupied space.
So you just try to get what the average,
You try to get it to average.
Okay.
One of the things that's happened with lighting controls in a lot of our buildings, the stairwells and corridors, is where some of the codes haven't caught up with the technology that we have. Up until just recently, the life safety code required you to have lighting in your egress pathways whenever your building is occupied. So that means you had to have the lights on in all hallways and in all stairwells if anybody's in the building anywhere. So, you know, you pick town engineering and somebody's in their office on the 5th floor in the corner. Every hallway, every stairwell light on a Sunday afternoon when it's sunny outside has to be on. When we built the King Pavilion, we ran into this issue. We have all this daylight, but we had to keep all the hallway lights on when the sun's out. And we got a lot of questions and complaints. And so we worked with the code official's office, and we now have a finding that we have a variance for the campus that if there is daylight present and you're above a certain lighting level, we can turn off the lights in the hallways and in the stairwells. So it means on most, any average day, except if it's a really dark thunderstorm, snowstorm outside, the lighting sensors will allow us to turn the hallway lights off because there's more than enough light to see where you're going. But if there's an emergency, it kicks on that all the emergency lighting comes on. And then at night, we have a lot of things now tied to motion sensors in these areas so that you may have a very minimal lighting in some stairwells. And you'll notice in some buildings, Bessie, Cat, I know our building, some of the others, that as you start down a stairwell, you'll have a low light level, and then it sees you on the landing coming down, and it turns this landing light up to full from low. Again, it's a controlled energy savings. We're allowed to finally do that. The life safety codes are starting to catch up with the technology that the energy codes and everything else is pushing.
so you actually were able to convince the code people,
Yeah,
because it's really hard to do that.
I mean, you have to put the argument together, and we have a very good relationship with the code official's office. We have somebody here on campus that we work with environmental health and safety, but we work with pretty much have a single individual down at that office, and we were able to lay out the argument of, here we are with King Pavilion, a daylit building where the exit corridor is all windows, and we have the lights on. And they agreed that was kind of ridiculous. And we said, if we do these following controls, that if the light levels fall below 10-foot candles, which is more than light enough in a corridor, or there's an emergency situation, then the lights will kick on full blast. And they said, that's very reasonable. So we were able to do that.
Okay, the last two questions, I think you answered them in the course of talking to them. So on your final thoughts, do you think this project was worth the extra investment in adding those green initiatives? And would
I
you
do.
recommend-
The approach that we take when we're dealing with our green buildings is that we don't want to buy something just because we want to get another level of lead. We just don't. We have to be smart users of the university's resources, which are the state's resources and the donors' resources. So, there have been only 2 cases where we went out and, one of the places, there's a lot of things people talk about buying a lead point. Really about the only one that you really buy that's not useful for much of anybody is green power. You buy a green power RAC, because the way we do our energy, we don't have certified, we don't have the ability to certify the amount of power we bring to campus that's like from the wind farm. 8% of our average energy usage per year comes from the wind farm. But we don't have credits that we can say 8% of this energy came from here. So we buy green RECs, which are it's really kind of like carbon credits, buying carbon credits. It's not that you're getting anything for it. What you're doing is you're investing in resources that are going to help improve the environment, be it help fund green power sources throughout the country, help plant more trees, help educate about the use of green power. We have only done that on 2 projects, and that was done because we were so close to platinum or right at the platinum level. And when we go into review with the USGBC on LEED, you've got the levels that they certify at. So a certified project is, right now is 40 points. A silver project is 50, a gold is 60, and a platinum is 80 credit points. If you go in right at 50 points or at 60 points, or in the case of platinum, right at 80, our experience has shown us that the reviewers grade extra hard because they're gonna really dig into every piece of work that you're showing. And we have yet to have a project go in for any review and not have something rejected. So you always want just a little bit of cushion when you're going in. And our platinum projects are really, really good. They're really something we're proud of. And for us, the investment of those 2 credits that were associated with that really wasn't a major investment. In the realm of things, you know, it was less than $5,000. When you're dealing with a project that's $50 million, 5,000 is, you know,
Yeah,
really not, we don't see it as a waste of money.
okay.
And, you know, the only time that we've had arguments, you know, and this is an ongoing interpretation of, does LEED force you to spend money you wouldn't normally spend? What we're doing, probably the biggest expense that comes in it is on the paperwork side. It's the people time to show your work, because really what LEED is making you do is show your work on all the decisions that you've made and how you've done it. You know, with contractors, you know, with recycled waste, they have to give us all of their waste hauling tickets. They would collect them anyway because that's how they pay their bill, but we're saying, show them to us. You know, it's just sort of like a math or a chemistry exam. Here's the equation. Don't just tell me the answer is 12. Show me how you got there. And that's really what LEED forces you to do. So, you know, the biggest expense that really comes in is there is some cost in the LEED filing, but it's the time that people spend. But for us, I see it as really justifiable for the university because this is an internationally recognized tool, kind of like the nutrition label on the box, that helps you evaluate it. And somebody is looking at it. It's not you just saying, hey, I built a green building. Well, how are you going to prove it? Show me, you know, we're proving that we are walking the talk when we do this. And we can say that, you know, based on a code building says it's going to use this much energy or this much water. What we've done shows us that we have saved 30% of the cost of the energy or 97% of the water consumed. You know, we can show our work and prove it. And for me, that's really important because it shows that we are a green institution. We are proving publicly what we're doing. So
So do you have any more questions?
No.